Hello everyone, welcome to my new lesson video. In this lesson video, I will be discussing the domain and range of functions. In this video, I will define what is the domain of a function and what is the range of a function and how to determine the domain and range of a certain function. I am your teacher, Sir Mark Laroya. So let us first define domain and range. So when we say domain of a function, it is actually the set of all numbers or values allowable for our x for our given function. And when we say range, this is the set of all numbers that is allowable for our y or the f of x. Or we can also say that since our y is our dependent variable, we can say that range is the set of all possible values for our y or f of x. So for example, we have here a function f of x equals x plus 3. So this is an example of a linear function. As you can see here, we can actually assign any value for x without any restrictions. So let's say you assign a negative value, a positive number, or even 0, there is no problem for x. So we can say that the domain of our function f of x equals x plus 3 would be x such that x is any real number. And for this type of function, always remember that our domain will always be like this: x such that x is any real number, and automatic our range will also be y such that y is any real number. So I have here a table of values to prove that our domain is this one and also for our range. So let's say the value of our x will be negative 5. So if we substitute this value of x to our function, this is now negative 5 plus 3. We will have negative 2. If x is negative 3, our y is equal to 0. If x is 0, this becomes now 3. And if our x is 4, this becomes 7. So as our value for x becomes more positive, the value of our y also becomes more positive, or to positive infinity. And if our x goes to negative infinity, same goes for our y. And that proves that our domain and range are correct. Now, let us now determine the domain and range of this particular function. We have here f of x is equal to x squared minus 4. So this is actually a type of quadratic function. Now, I will be using this table of values for us to analyze what should be our domain and range for this particular function. Let's say whatever value we use for x, let's say a negative or positive, that since this will be squared, the result will be always be positive. So for example, we have negative 4 or 4. If we substitute this to our function, it will be squared. So this becomes now 16 minus 4. This becomes 12. If we use negative 3 or 3, this is now 9 minus 4. This is now equal to 5. And for this one, negative 2 or 2 squared, it will be 4 minus 4, 0. Negative 1 or 1 squared is 1 minus 4, negative 3. And if our x now is equal to 0, so 0 minus 4, you have negative 4. So as you can see, if the value of our x is going to negative infinity or to positive infinity, the value of our function f of x or our y is also going towards positive infinity. And that means if our x is 0, we will have a value of negative 4, which is the minimum value for our f of x or y. So we can say now that the domain of our function is x such that x is also any real number. So either positive, negative, or even 0. There is no restriction for our x. While for the range, for the possible values of our function, as you notice, the minimum value for this function will be negative 4. So we cannot say that y such that y is any real number. It's because we have only a minimum of negative 4 and above negative 4. So we can say now that the range of our function is y such that y is greater than or equal to negative 4. So this is how we get the domain and range for this quadratic function. Let us now try to determine the domain and range of another function. So we have here f of x equals x plus 2 all over 3. So this one may seem to be a rational function, but actually if you substitute or if you change f of x into y, so this one will become like this, and if you simplify this equation, it will turn out to be a linear equation. So we can say that this is just like a linear function. So if our function is just like a linear function, so our domain will be x such that x is any real number, and same goes to our range y such that y is any real number. And this table of values prove that our domain, okay, the value for x can be any real number. It can be any negative number or any positive number or even 0. And for our y is the set of all possible values for y or our f of x. So you have here, it can be negative value, a negative value, or positive, or even 0. So there is no restriction for this function. No restriction for the domain and for the range. Now, for our next function, we have here a rational function. So when we say rational function, it is a function with a fraction, and also the variable appears on the numerator and on the denominator. So we have here f of x equals 4x minus 1 all over 2x plus 8. So in this type of function, we have no problem with the value of x, any value for x for the numerator. But our concern here is the value of x on the denominator. Since we have here a fraction, we are concerned of avoiding the value of our denominator into 0, because this will make our function undetermined. So we must not have a value for x that will make this denominator equal to 0. So let us focus on the denominator of our rational function, so that is 2x plus 8. And as I've said, our denominator should not be equal to 0. That is why I write here 2x plus 8, which is our denominator, should not be equal to 0. So just like the ordinary equation, we can transpose this 8 on the right side of the equation. So we have 2x is not equal to negative 8, and therefore if we simplify this by dividing both sides by 2, x is not equal to negative 4, or should we say x should not be equal to negative 4. It's because if our x is negative 4, 2 times negative 4 is negative 8 plus 8, our denominator will become 0. And that is the one thing that we try to avoid, to become 0. So this value of x, negative 4, is the restricted value of our x. So this will be the restriction of our domain. So we can now say that for our domain, x such that x is any real number, but using a comma, x should not be equal to negative 4. So this serves as the restriction of our domain. So it can be any real number. It can be negative 5, negative 3, or negative infinity, positive infinity, or even 0, but except for negative 4, because this makes our function equal to this makes our denominator equal to 0. And so in determining now the range of this rational function, what we're going to do is identify the term on the numerator that has the variable x. So that is 4x. And determine the term on the denominator with the variable x. So that is 2x. And we have 2x. So what we're going to do now is divide those two terms. 4x divided by 2x equals 2. Now this 2 is actually will become the restriction of our y, or the value of our y, meaning our function or y will never have a value equal to 2. And so our range now will be y such that y is any real number, but y is not equal to 2, or should we say y will never be equal to 2. So there is no way that our function will be equal to 2. So that is how we get the domain and range of different kinds of functions. So thank you very much for watching my video. If you think this is helpful, please don't forget to like and share this lesson video to your friends and classmates. And also, subscribe to my YouTube channel, Sir Mark Laroya. Again, thank you, see you again next time, and God bless.